Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is object oriented programming, and the same chapter, that is chapter number 10, that is managing console input output operations, that is how to manage the input output or various input output operations in C++. That is when to give the input, how to process them, and when to give or take the output. That is a input output operations, that is a management of input output operations. So the first topic, or the let's start with the topic that we have covered in the last class, then moves to the today's topic, that is how to use the setf function. So in the last class we have discussed so many manipulators. I'm continuing with the same, that is setf, and after the break, that is after the 1 hour session, there will be a practical approach. We will going to the practical approach, right? So let's start with the previous class session. In the last class we have discussed with the formatted console input output operations. So in the last to last class we have discussed only the unformatted. The main criteria is that we have to use the input output operation, but there is no formatting that is available. But the next concern is that the formatted in console input output operation, that is how to format the input output operation, so that there will be a proper line space, there will be a proper margins, there will be a proper gesture, everything is according to the user requirement. That is, everything is formatting according to the input output operation. So that is a formatted input or console input output operations. So C++ supports a number of features that could be used for formatting the output. These features include, so these are the features that is include, that is in formatted there are three features that is available. One is the iOS class function. So we have studied about 5 functions that is available for the input output stream. And then next is manipulators, and next is user defined output functions. There are three features that is used for formatting the console input output operations. The first one is input output class function. So there are 5 functions that is total available. One is the width, then precision, then fill, then setf, then unsetf. In the last class we have discussed 3 that is a width, precision, and fill. In the today's class I am going to continue with the setf and the unsetf function. So width is used to specify the required field size. That is, if I am going to specify the field size as a 5, that is there are total 5 columns and the numbers are shifted to the right. And the precision, that is how many numbers are available after the decimal point, that is to specify the number of digits to be displayed after the decimal point. Then fill, to specify a character that is used to fill the unused portion of a field. That is, suppose there are 5 blank spaces, that will be filled by the fill function, right? And the manipulators that is available is set w, set precision, set fail, set iOS flags, and the reset flags, that is equivalent to these functions. So in the last class we have discussed about the width, precision, and the fill. We have started with the width function. So first is the width function, that is how we are creating the width function, that is a user defined function. So we can use the width function to define the width of a field. The syntax that is available is the cout width. Suppose the same example, if I'm giving the 5, that is the 5 columns are allocated to it, that is there are total 5 columns, this is allocated to it, this is 4 5 4 4 5 4 3 and the 1 2, that is it is allocated to the right, that is 5 4 3 and then 1 2. So this is printed in the right justified in the 5 columns. So this is 5 4 3, these are the 5 columns, this is 1 2 3 4 5, and the 543 is right justified to the next one. The specification width does not retain the setting for printing the number 12. That is, it is not available for printing the or for printing the number 12, but it is available for specifying the width that is available for the 543. That can be improved, or this can be improved as follows. So this is the way how it will be improved. That is cout width 5, then cout 543, then cout width 5, then cout 12. That is the width is 5, and there is a number that is available, that is 543. Then again the width is used, that is 12. Now what is the output? Like this is the output. This is for the 5 width, that is a 5. This is for the 5 width, that is a 5. That is 1 2 3 and the 4 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. This is the example that we have discussed in the last class, that is how to specify the field size with the width function, that is how to use them with the width function. And these are the arrays available, that is the items. There are 4 values. Then cost, again there are 4 values. Then there is a width that is defined for the items, cost, and this is the for loop that we have discussed, that is how to print it with the help of a width. Today I am going to continue with the practical approach of these examples also, that is the width fill function, so that your concepts are clear, right? So I will skip over here. Now next is precision function that we have discussed in the last class. To we can say to how many numbers are available, or to specify the digits, number of digits that is available after the decimal point. So by default the numbers are printed with the 6 digits after the decimal point, that it is not going after the 6 points or 6 digits, but it is going till 6 digits after the decimal point. That is by default, but we can specify the number of digits to be displayed after the decimal point while printing the floating point numbers. That is by default it is 6, but we can specify our own numbers, we can specify our own number of digits that is displayed after the decimal point. This can be done by using the precision function member function as follows. So this is the precision function that is available. There is a cout precision d, that is d is the number of digits to the right of the decimal point, that is how many digits are available after the decimal point. This is the example, cout precision, then square root of 2. Yeah, this is one important point. When we use the width function, that is only available for the one point, and that is available for only one field, and then it is always set to the default value. But when we use the precision function, this is common, or this is available for the whole of the word, whole of the line, whole of the document, whole of the we can say the every number, it is printed with the precision 3, that is cout precision 3. So this is 1.141, that is truncated, then 3.142. Why? Because only 3 digits are available after the decimal point, so this is 142. Then 2.5, why? Because there are 2 zeros, so this zeros will be truncated or not used, so this is 2.5. In the same way, these are the various examples that we have discussed, that is how to reset the precision. Suppose there is a requirement to reset, again modify or again use the precision function, that is also done by using the reset the precision. The first truth statement instruct print 2 digits after the decimal point in a field of 5 character width, therefore the output will be this one. This is the program that shows how the width and the precision functions are jointly used to control the output format. This is the precision setting with the precision function, that is how to use the precision function. There is a hash include iostream.h, there is a math.h, that is a precision will be taken against up to the 3 digits. Then cout precision, then the width will be specified, then the value, then cout width. Then this is the for loop that is used. There is a width of the 8 character, or there is a width of the total, we can say the 8 columns will be allocated to the n. Then for the square root 13 columns. So this is we are doing in a practical approach. Then we have discussed the fill function. So we have seen that when we specify the width, that is, for example, if I am specifying the width of 5, the same example over here, this is the same example, this is the same example, this will be blank 1 and 2, this will also be blank 1 2 3. So this will be filled, or these blank spaces will be filled by the fill function. So this says we have been printing the values using much larger field width than required by the value. That is, we are using the width size as a much larger than that is required by the values. The unused position of the field are filled with white spaces. So every unused portion is filled by the white spaces by default. However, we can use the fill function to fill the unused positions by any desired character. It is used in the format. That is how it is used. Suppose I have to fill the asterisk, so that will be filled by the asterisk in a single quote. That is a character. So this is the width, that is 10 is allocated, and there are only phone numbers. So these are the phone numbers, and then 6 or we can say the 6 blank spaces are filled with the asterisk. Why? Because we have mentioned the it is filled by the asterisk sign. It is generally used by the banks when they are offering or when they are giving us the DD, that is a demand draft, checks, or any pay order that is available. So they are putting the asterisk side so that no one can change the amount easily. So there is no forgery, there is no fraud, there is no easy detection. This is the program, that is how to use the padding with the field, that is how to fill the blank spaces. This is the example that we have discussed. In 3 there is a this sign, in after 3, that is 4 5 6, there is a this sign, and the padding will be changed, that is the hash will be changed. Now the next is setf function, that is a today's class function, that is how to use the setf function. So let's start the today's session. Today's class topic, that is setf function. This is, we have seen that when the function width is used, the value, whether the text or the number, is printed right justified in the field width created. That is, whenever we use the width function, suppose we have used the 10 width, so when we given the values as a 5 4 2 3, so it will print it, or it will going, or it will we can say the it will print it right justified in the field width that is created. So it is going to the right hand side, but it is a usual practice to print the text left justified. So it is a user practice, means by default the text will be, the numbers will be left justified. So how this conflict, or how this convertency will be resolved? So how do we get a value that is printed left justified, or how we can get a floating point number printing in the scientific notation? So these are the requirements, that is, we have to print the values in our left justification, we have to print the characters in the right justification. The first, that is the setf, a member of the iOS class, can provide answers to these and many other formatting questions. So setf is used to give the formatting, to give the settings of the right justified field. The setf, that is the setf stands for the set flags function, can be used as follows. There is a cout.setf argument 1 and argument 2. So that is a cout.setf, that is a setf is used, then there are two arguments that is used, that is the argument 1 and the argument 2. This is the syntax that is used. The argument 1 is one of the formatting flags that is defined in the class iOS. So this is one of the formatting flag that is available in the iOS. The formatting flag specifies the format action that is required for the output. That is, what is the action, or what is the formatting action, or what is the formatting flag that you need, that is required for the output. That is, what are the formattings that is available for the output. Another iOS constraint, that is argument 2, known as the bit field, specifies the group to which the formatting flag belongs. So it is, or it defines the format by which it belongs to the flag, or argument 2, that is known as the bit field, that specifies the group to which the formatting flag depends or belongs. Table 10.4 shows the bit fields, flags, and their format actions. So what are the bit fields, what are the formatting flags that is available, and what are their format actions, that is what are the actions that is provided by these formatting flags. There are 3-bit fields and each one has a group of format flags which are mutually exclusive. That is, there are total 3-bit fields that is available, and each has a, that is, every or the each bit field has a group of the format flags which are mutually exclusive. The examples are cout.setf, iOS left, iOS adjust field. That is, the setf is used, and then iOS left, that is the input output stream is used as a left margin, and iOS does adjust field, that is the how to use the or using the field, that is the adjust field. Then next example is cout setf scientific and the float field. That is, the float field will be uh, adjusted to the scientific field. Note that the first argument should be of the group members of the second argument. The following section, this is the fill function that is filled with the asterisk, then setf and iOS left, iOS adjust field. Then cout width 15, there are total 15 width, then it is printed table 1. So this is print like this one, there is a table, and then there is a gap of space, there is a gap, and then there is a 1, and then there is a asterisk signs. Why? Because it is available that the setf, that is set the field to the left hand side, adjust the field, that is adjust the field to the left hand side. This table 1 will be printed to the left hand side. And how many spaces it is available or it is occupied? There are 1 2 3 4 5 6 7, and after 7 there are total 15 cells, so 8 will be occupied by the or filled by the asterisk. This is 1 2 3 4 5 6 7 8. These are the 8 asterisk that is available. So in simple terms, when we want that the field will be or would be the left justified, so we can simply give the setf or simply use the setf function, that is iOS left, iOS adjust field. So this is the various flags and the bit fields for the setf function. So this is the format that is required. Then there is a flag, that is argument 1. Then there is a bit field, that is argument 2. That is how many arguments are required? That is 2 arguments, as we have discussed earlier also. So in argument 1 there is a flag that is required. In argument 2 there is a bit field that is required. So there is a requirement of the bit field, that is argument 2. And the format required is left justified output. That is we want the output as a left justified. There is a iOS left, this is the iOS adjust field. Then right justified output, this is the iOS right, then this is iOS adjust field. Then padding after the sign or the base indicator, like this one, this is the that is a padding after the sign. So there is a sign padding after the sign, that is a plus, or base indicator, that is a base indicator that is available. This is iOS internal, that is a internal flag will be used, that is it is occupied in the internal, in the middle, that is iOS internal and the iOS adjust field. Then for scientific notation, there is a flag that is required, that is iOS scientific, and the bit field that is required is the float field. Then in a fixed point notation, there is a argument 1 that is used, that is the iOS fixed, and the bit 2, that is the argument 2, that is the float field. Then in a decimal base, there is a iOS decimal, and then there is a iOS base field. Then in octal base there is a iOS oct, and then there is a iOS base field. In hexadecimal there is a iOS hex, that is a hexadecimal, and then there is a iOS base field. Right, so these are the various arguments, that is these are the various argument 1 and the argument 2, and there are various format specifiers that is required, that is a format required. So one is a left justified output, then there is a right justified output, then there is a padding, that is there is a gap between the value and the sign, that is there is a plus sign, and that is a value between the operand and the operators, then scientific notation, then fixed point notation, then decimal base, then octal base, and the hexadecimal base. So these are the various, we can say, the setup, or these are the various format that is required for the setup function. So this will produce the output will given as follows. Then the statement, that is a cout fill asterisk. So there is a asterisk sign, that is fill. Then cout dot precision, that is a precision function is used, that is after decimal point there will be a 3 digits, that is a cout precision. Then cout dot setf, that is a setf is used, there is a internal, that is there is a gap, or there is a sign, or there is a number, there is a argument that is used between the number and the symbol, or number and the sign. Then iOS scientific, that is a scientific notation is used. Then cout width 15, total width will be given as a 15. So first of all, there is an internal and the scientific notation. So this minus 12 plus 34.13, this is scientific notation, this is a 1, there is a minus sign. In an internal there is a gap that is filled with the asterisk, and there is a minus sign first of all because it is an internal specification, then 1, then dot, then 2, then 3, 5, E plus 0, 1. So this will be changed into the scientific notation automatically, this number, right? The note is given that the sign is left justified and the value is right justified. Why? Because we have used the internal, that is the internal means there is a gap, or the filled the symbols will be filled with the, or the sign will be filled with the internal level, that is the sign is the left justified and the numbers are the, or the values are the right justified, and the internal is filled by the cout dot fill function. The space between them is filled with the stars. So why? Because we have given that it is filled with the asterisk, it is we have given already that it is filled with the asterisk, so this is filled with the asterisk sign. The space between them is padded with the fill, so it is available with the fill. Yeah, I'm so sorry for the delay. So let's continue the session again. So this is the internal, that is this operator, this minus sign will be available at the left justified and the value is on the right justified. The space between them is padded with the stars. Why it is padded with the stars? Because it is already given that cout star, that is it is filled with the star, that is the margins will be filled with the star, right? Then this is the plus 1, the value is printed accurate to the 3 decimal points. Why? Because we have already given that this is the precision of 3, so this is available up to 3, that is 235 only in the scientific notation. Now how to display the trailing zeros and plus sign, that is the next topic, that is how to use the trailing zeros and the plus sign that is available. So if we print the numbers 10.75, 25 and the 15.15 using a field width of say 8 positions with 2 digits precision, then the output will be as follows, that is 10.75, then 25, then 15.5. Note that the trailing zeros in the second and the third items have been truncated, that is second item will be truncated by the zeros. Then the setf can also be used with the flag iOS show point as a single argument that is given to achieve this form of output. That is, it is available with the iOS format, it is available with the iOS show point as a single argument, as a we can say the single operator that is used to achieve the single form of output. For example, this is the output that is given, that is a cout.setf, that is a setf is a function that is available, and there is a iOS show point that is display the trailing zeros with cost cout to display the trailing zeros. So there are trailing zeros that is available and the trailing decimal point that is available to show the point. Under the default precision 3.5, that will be displayed as a 3.2500000. So it will be showing the trailing zeros also. So if I want that the trailing zero will be displayed, that is done by using the cout iOS dot show point. This will be used as a single argument to achieve the some form of output. Under the default precision, the value 3.5 will be displayed as a 3.250000. This is the trailing zeros that is available with the 3.5. In the same way, a plus sign can be printed before a positive number, that is using the following statement. That is a cout.setf ios show positive. That is, every number or the positive sign will be shown, that the plus sign will be shown by using the ios show positive. That is, the show positive is the IO stream show positive. So this is the example that is given. There is a cout setf, that is, a setf will be used again for showing the output. That is a cout dot setf, that is the ios show point, then cout dot setf, then ios show position, then cout dot precision. So this is the showing the trailing zeros. Also, this is used for showing the positive sign. This is used for giving the precision, that is the number of digits that is available after the decimal point, as a 3. Then cout.setf, there is a fixed, that is a fixed size or the fixed interval. Then there is a float field. Then ios internal, that is we can say the operators will be justified to the left and the numbers will be justified to the right. Then cout width 10, that is the width will be given as a 10, and there is a 275.5. So now this is the output. First of all, this will be used as an internal. The width is total 10. There are 1 2 3 4 5 6 7 8 9 10. There are total 10 columns. Then the plus will be allocated, or plus will be assigned to the left justified, and the numbers will be assigned to the right justified. So this is the left, that is a plus. Then there is a blank cells or the blank columns. Why? Because this is the internal. Then 275.500, this is a show point, that is showing that leading zeros or the trailing zeros, and the plus sign is also used. Why? Because we are used the show positive sign, right? This is 275.5.5000. This is displayed as it is. So we are using the multiple flags, multiple format parameters in this space. The flags such as show point and the show positive do not have any bit fields and therefore are used as a single argument in the setf. So they do not have any bit fields. So it is showing as it is, like ios show point, ios show positive. There is no ios fix, ios internal, nothing, but it is showing as it is. This is possible because the setf has been declared as an overloaded function in the class iOS. Table 10.5 lists the flags that do not possess a named bit field. These flags are not mutually exclusive and therefore can be set or declared independently. So these flags are not mutually exclusive, not used in a mutually exclusive, but that can be used in a single way, that can be used for the multiple options that will be used in a single option. So these are the various flags, and this is the meaning of various flags. So these are the various meaning. Wait for only 2 minutes. I'm just coming. So this is the various flags that is available. For the first flag that is available is the iOS show base, that is a use the base indicator as an output. Then show positive, that is a print plus before the positive number, as we have seen over here. This is a show positive. There is a plus sign that is available over here. Then show point, that is shows the trailing decimal points and the zeros. This is a show point. This is used, and there are the trailing zeros that is available over here. Then uppercase, that is the uppercase letter for the hexadecimal output. That is, only uppercase are used in the hexadecimal output, right? Then unit buffer, that is a skip us, that is a skip white space on the input. Then unit buffer, that flush all streams after the insertion. Then stdio, that flush the std out and the std error after the insertion. This is the program that shows how to use the various formatting flags using the overloaded setf function. That is how to use the overloaded setf functions. So this is the formatting with the flags in the setf function. This is the example that is given. So first of all, there is a header file, that is iostream.h. Then there is a cmat.h. Then there is a int main, that is the starting of the main. Then cout dot fill, that is it is filled with the padding sign, it is filled with the asterisk sign, that is any margins, any blank spaces, any blank columns, or any blank cells are filled with the asterisk sign. Then cout setf iOS left, that is every we can say it is adjusted, or it is verified, or it is margin to the left side. Then cout width 10, that is in total of the 10 columns are allocated, that is a width 10. Then cout value, that is a value character or the value string will be printed, that is a value. Then cout.setf iOS right, now this will be allocated to the right, again the adjust field, then cout width, so it will be printed in a 15 column, that is a square root of value, that is a sqrt of value. Then it is filled with the dot, then precision, that is only 4 decimal points are used after the decimal point, 4 digits are used after the decimal point. Then cout.setf show point, that is it is showing the point, it is showing the, we can say, the trailing zeros. Then show positive, that is a plus sign is also used, and the iOS fixed, that is it is fixed with the left margins and the right margins. Then the for loop is used, it start with the 1, it ends with the 10, and there is a n plus plus, right. Then cout.setf, then iOS internal, that is internal means the operators are assigned to the left, and the numbers are assigned to the right. Then there is a cout width 5, that is a 5 will be 5 columns will be allocated, that is a width 5, then it will print the n. Suppose it is print 1 first of all, then 2, then 3 till 10. Then cout setf iOS right, then it will be right justified. Then cout width 20, that is there is a width of the 20 characters, so there are total 20 columns that will be assigned. Then cout square root of n, that is a square root of n will be printed. That is the square root of 1 is 1, that is printed. Square root of 2, square root of 3, square root of 4 until square root of 10, and it will be allocated, or then the next line will be used for moving to the next line. Then the float field change, this float field will be changed. Then again the cout.setf, that setf will be used. Then again the scientific, then again the float field, then the square root of 100 equals to square root of 100. Then there is a return 0, that is a return 0 will be used. So the output will be like this one. So first of all, the value will be printed as a value in a width of, in a columns of the 10 values, and the left justified, this is the value, that is the left justified. Then there is a asterisk, these are the various asterisk, and then it is printed the square root of value. So this will printed in the by these two lines. First of all, there is a value, that is a left justified, then the square root of value, that is a right justified, and the middle value, that is middle blank spaces are filled with the asterisk sign. So this is the asterisk, and there is a value and the square root of value. Then it is showing internal, that is it is showing the internal values, showing the positive sign, it is fixed, showing the we can say the show the points. Then there is a precision, that is a 4 characters will be used, and it is filled with the dots one by one. So first of all there is a plus, then there will be a dot, then there will be a 1. Why? Because we have given the width of the 5. There will be 5, this is 1, then 2, 3, 4, 5, and this will also printed, that is a plus 1, that is a square root, that will be assigned to the right in a total of 20 characters. Then plus 1 0 0 0 0. In the same way, n equals to 2, this is the square root of the 2, then 3, then 4, then till this one 10, and at last this will be changed. This will be used in the scientific. The square root of 100 is square root of 100. This will print as it is. It is the square root of 100. So this is the program that shows how to use the square root, how to use the value, the square root of the various values, right? No, there are various nodes. That is how to use the various nodes. This says the flags that is set by the setf function. So the flags that is set by the setf remain effective. So this is set by the setf function that is used, remains effective until they are reset or unset. Then a format flag can be reset any number of times in a program. So it can be reset, the float field will be changed, it is reset to the number of fields. Then a format flag can be reset any number of times in a program. So it is showing in n number of times in a program. Then we can apply more than one format controls jointly on an output value. So we can apply more than one format control that is used jointly on an output value. Then the setf specifies the specified flags and leaves other unchanged. So it is specified only the value that is available and left the unchanged value, other values as unchanged value. So this is the setf function that is also used. Now next is managing the output with the manipulator. That is how to use the manipulator. These are the various manipulator that is used. I'm not going to continue right now, but I am taking the break only for 10 minutes, max to max 10 minutes, because today the time is also wasted. Only to 5 to 7 minutes or max to max 10 minutes. So we will come back after the break and move to the practical approach, so that your practical approach will be followed, or your practical approach will be carried out what we have covered in the last class, that is a width, precision, fill. There are so many programs that will be done in the practical approach. So let's take a quick break. After break, then continue with the practical approach. So let's take a break right now. So come back from the break. Now let's start the session again. So let's move to the practical approach. This I am taking in the next class, that is how to manage the output with the manipulators. So let's move to the practical approach, that is how to use the width function, carry function, how to use them. So let's move to the practical approach. That is how to specify the width, how to specify the field that is given in the width function, specify function, how many functions that will be used. What happened? So there is a program that shows, that is specifying the field size with width function. Now starting with the header file, that is a hash include iostream.h, then hash include conio.h, then there is a int main, that is a main function, then there will be a curly braces, then int items 4, that is equals to, then there will be a curly braces, that is a 10, then 8, then 12, then 15. Then next array that will be used, that is a cost, that also contains 4 values, that is equals to 75, 100, 60, then 99. Then cout dot width, that is the width operator is used, or the width argument is used, that is a cout dot width. Then it contains total 5, for example the 5. Then it will print as it is, that is a cout. What will be the print? That is the items, right? Then cout, again it is using the cout dot width. Now it is using, for example, 8. Again there is a cout, that is a display, that is the, it will display the cost in the capital letters, right? Then again the next line it is given, that is a width as a 15. Then cout, that is the total value, that is equals to slash n, right? Then int sum equals to 0, that is sum equals to 0. Then for loop will be used, that is int I equals to 0, I is less than equals to or less than 4, then I plus plus. Then cout dot width, that is contains 5, or that takes 5 values. Then cout, then there will be items that will be printed, that is the items. Then there will be a I. Then there is a cout dot width, that contains total 8, for example. Then cout, then cost, then there is a I. Then int value, that is equals to the items, that contains I, that is multiplied by cost, that is the value is multiplied by the cost. Then cout dot width, then 15, then cout, that is a value that is printed. Then there will be a slash n. Then sum equals to sum plus value. Then there will be a closing curly braces. Then cout, then there will be a slash n, then there will be a printed, that is a grand total. That is equals to, in double quotes it is a semicolon. Now again it is using, that is the width, that contains 2, then cout, that is sum, then slash n, then there is a return 0, right? Then this will be closed, that is this will be closed, that is int main will be closed. But before this, that there is a get ch for displaying the output, and there is also a clear screen. Now if I compile this code, there will be no error. If I execute this code, this will print as it is, that is item, that contains 10, the cost that contains 75, so the total value is 750. In the next item that contains 8 and the cost is 100, that contains 800 value, then 12 60 720 value, then 15 99, that is a 1485 value, and the total of these values will be the grand total, that is the 3755. That is the totality of, or the total of the various total values. Now this 8 10 8 12 15 75 100 we have already given, so this will multiply by this one, this will be multiplied by this one, this will be multiplied by this one, this will be multiplied by this one, and at last the total value will be generated, and after that the total will be calculated, or the addition of these total value will give the grand total. This is the usage of the width function. That is how this output will be printed in a proper manner. That is done by the width function, right? So let's start with the first point. So first of all I will save this file, that is the width, right? So first of all there is a hash include iostream.h, that is a header file, then hash include conio.h. So first is the iostream, that is the input output stream header file, then conio.h, that is a common input output file, then there is a int main, that is the starting of the main, then the array will be declared as items that contain total 4 values, that contains 10 8 12 15, right? Then the cost is also array that contains total 4 values, and that also contain 4 values, that is 75 100 60 99. Then there is a clear screen for clearing the screen, that is clr scr, then cout width, that is we can specify the width as a 5, so there will be a number of columns that is denoted as the 5, and this that will be printed, that is a item. So if I see the output, oh, that will be not good. Now if I compile again, this will show the output. So this is a see, in the items there is a total margins of total width of the 5 characters, or the 5 columns, so that will be printed items, that is a items, right? In the same way there is a width of the 8 that contains the cost, so there is a gap of the 4 characters, so there is a gap like this one, there is a gap of the 4 characters after the items s, there will be a gap of 4 characters, then the cost will be printed, right? Then there the cout width, that is a more width will be given, more number of columns will be given, that is a 15, to take the more gap, to take the gap between the cost and the total value. Total value contains uh, total 1 2 3 4 5 6 7 8 9 10 11 11, so there is will be a gap of the 4. Why there will be a gap of 4? So that there is a consistency, there will be a same gap between the items and the cost, and the cost and the total value. That's why it is given, or it is mentioned 15, because there is a total of the 11 characters including space, and there will be a 4 margins, so there will be a total 15 columns. So this is these 3 lines will be used only for showing the output. These 3 lines only for showing the headings, not output, only the headings with the proper indentation, with the proper margins, with the proper gap. Then int sum equals to 0, that is the sum will be assigned as a 0 value. Then it start the for loop, it start with the 0 and with the 4, so it executed for the 4 runs, 0 1 2 3, so it start with the 0, it's end with the 4, then there is a I plus plus. Then cout dot width 5, that is the 5 columns will be allocated, then cout items I, that is first of all the I, that is a 0 value will be printed, then 1, then 2, then 3, there are total 4 values that will be printed. So this is printed as it is. In the next line there will be a gap of 4, that is items. First of all there will be a items that contains, there will be a 10, then 8, then 12, then 15. In the same way there is a cost, that is 75 100, 60, 99. There is also a 8, that is a margins of the 4 values. So there is a consistent gap. Then again, the value will be a variable that contains the items I, that is the first item, that is the I, that is this one, that is 10, that is multiplied by 75, then 8, that is multiplied by 100, then 12, that is multiplied by 60. That is the I value of the item is multiplied by the I value of the cost. Then see out with 15. Again there is a 15, so that there will be a gap of the 4 values, there will be a gap of the 4 characters. Then see out value. So whatever the value, whatever the output that is given, that is multiplying by the items and the cost, that will be available in the value. Then sum equals to sum plus value. Whatever the value that is available in the value, that is added with the sum, because sum contains first of all 0. So this is 0 plus any value that is available, so it will sum up all that values, that is a total value that is given. Then it is printed, that is see out grand total. There is a width of the 2, then simply prints the sum in the next line. This is how the output will be generated, that is how the width function will be used, how we are using the width function for showing the various values that is denoted, or that is occupied, or that is generated by seeking the items and the cost. That is the I value of item is multiplied by the I value of cost. I value of next value of item will be multiplied by the next value of cost. So these are the various values that will be printed. So this is how the width function will be used. Now if there is any doubts, or this program is clear to each and everyone. Yeah, this program is clear to Larry and Benjamin, both of you. Hello. Yeah, this program is clear to all of you. Hello. Yeah, this program is clear to all of you. Hello. Shall I move further, or is there any doubt in this program? Okay, means this program is clear to you. All right. Okay. Now let's move to the next function, that is a precision function. Right. So next is the how to use the precision function. That is precision setting or precision function, or precision setting with precision function. Now again the same header file iostream.h conio.h. There is one more file, that is a cmath.h. Then there will be a starting of the main, that is int main. Right. Then see out, there will be a see out, that is a precision up to 3 digits. There will be a slash n, there will be a slash n. Then see out, dot precision, then there will be a 3, then cout dot width that contains total 10 values, then it will print in this one, that is the value, then again the width that contains 15 number of columns, then this is square root of number or square root of value, then again the for loop is used, then int I equals to 0, it start with the 1, that n equals to 1 for example, then n is less than equals to 5, then n plus plus, then cout dot width, then cout n, that is n will be printed, then again cout dot width that contains total 13, there will be a gap of the 5 characters, then cout that is the square root of a number, that is n, then moving to the next one, that is now again the precision will be set, the new precision will be set, that is the cout, in the next line it will be printed, that is the precision set to the now set to 5 digits, then again there will be a /n, then cout dot precision, then there will be a 5 characters total, 5 digits not characters, then cout, then sqrt, that is the square root of 10, that is equals to that is square root of 10, then again the 5. Hello, yeah, are you able to hear me? Hello, hello, hello. Yeah, are you able to hear me or not? Okay, all right. So this is the precision up to the 3 digits. There are various values. All right, Benjamin. There are various values that start with the 0 that ends with the 5. That is, it starts with the 0, it starts with the 1 and ends with the 5. That is 1, 2, 3, 4, 5. And the square root is also given. That is the square root of the value. That is 1. Then the square root of 2 is 1.414. Then square root of 3 is 1.732. Then 4 is 2. Then the 5 is 2.26 or 2.236. That is, there are total 3 decimal places that is available after the decimal point, because we have given the precision up to the 3 characters or the 3 digits. Now the precision will be set to the 5 digits. That is, the precision will be set to the 5 digits. Now the after the decimal there will be a 5 digits that is available. So this is the square root of 10 that contains total 5 digits after the decimal. That is 3.16228. Then square root of 10, that is equals to 3.162278. There are total 6 digits. Why? Because the default setting of the precision, as I told you, the default setting that is available is of 6 digits, right? So this is the example that shows we can give our own precision value, that is 3, 5, or the default value that is given is the 6 digits, right? Now let's see the program. First of all, I save the program so that it will be saved. Now, first of all, there will be a header file, that is a hash include iostream.h. Then the next is hash include conio.h. Then there is a math.h, that is a math.h is also available, that is also a header file that is available. Then int main, that is the starting of the main. Then the cout, that is, it is showing as it is, that is a precision up to 3 digits. Now the precision will be set as a 3, that is, after the decimal there will be a 3 digits that is available. Now next is cout width. Now the width will be assigned to the value, that is a heading. Value will contains the width 10. Now cout width 15, that is it is available in a 15 value. There are total 1 2 3 4 5 6 7 8 9 10 11 12 13. So there will be a gap of the 2 characters because it contains 13 characters, but the width is 15, so there will be extra of the 2 for making a gap between the headings, that is a value and the square root of value, right? Now if I show the output, there will be a gap of the 2 characters only between the value heading and the square root of value heading. But before the value, that is before the value word that is given before the heading value, there will be a gap of the 5 characters. Why? Because this is the 5 characters and the 10 is allocated, so the 5 will be assigned on the left. Next, for n equals to 1, that is the for loop is used. It starts with the n, it starts with the 1 and it ends with the 4. That is, start with the value 1 and ends with the value 5. So cout width 8. Now the width is 8. That is, the value 1 will be printed in a 8 width. Then the n will be printed, that is 1. Then cout width 13. That is, the 13 is used so that there will be a gap of the 5 characters. Then there is a square root of 1. If this is a 1, then this is a 1. Then there will be a moving to the next line, that is a slash n, backward slash n. Now next is n plus plus. Now the n becomes 2, so the 2 will be printed and the square root of 2 will be printed. So this is a function, predefined function that is available in the math.h. So this is the function that is used, that is the square root function is used to find the square root of a value, that is the square root of n, right? Then it will be moving to the next line, that is the square root of the n. Then next is cout precision up to the 5 digits. So it will be looping out, it will be carried out till 5 value. First of all, n equals to 1, then the square root of n, then n plus plus, that is n equals to 2, that is the square root of 2, then n equals to 3, that is the square root of 3, then n equals to 4, that is the square root of 4, then n equals to 5. Check the condition, 5 is less than equals to 5, condition is true, the 5 will be printed and the square root of 5 will be printed. Now there is a n plus plus. Now the n becomes 6, 6 is less than equals to 5. Condition is not true. So this will not print and this will terminate the loop. Now it is moving to the next line, that is set the precision up to the 5 digits. There will be a gap of 2 lines. Now the precision will be set of the 5 digits. There will be a square root of the 10. Now finding the square root of the 10 by using the function, that is the square root of 10. There will be a gap. So the square root of 10 will be printed with the precision of the 5 digit. That is, after the decimal there will be a 5 digit that is available. Then there will be a no precision, that is precision 0, that is it will set to the default setting, that is it contains total 6 digits because it is set to the default value, that is precision 0. So square root of 10 will be printed with the default setting, that is the default setting is total 6 digits after the decimal point. Then there will be get ch and the return 0. This is the output that is given. Now if I do not include this header file, now let's see, if I exclude this one, if I compile, there will be one error, that is the square root function should have a prototype, that is it should have a prototype means it must contain the header file. So this is very must for including in the header file whenever we use the function that is a predefined functions. Now if I compile, there will be no error, right? Now this program is clear to each and everyone. Now this program is clear to each and everyone. Hello, yeah, this program is clear to Larry and Benjamin, both of you. Yeah, sure. When you go through on your own, that concept will also concept will be more clear, right? So what about Larry? Larry, is that clear to you? Okay, so read it out, both the programs, so that your concepts are clear, and if there is any doubt you can ask the doubt in the next class, that is in the tomorrow's class. No issues, I will take the doubts. Now till now, if there is any doubts you can ask the doubts. So that's all for today's session. In the next class I will be moving your next topic, that is the managing the output with the manipulators, that is how to use the manipulators. Till now we have not used the manipulators, till now we have used the iOS function, that is a precision, width, fill, setf, unsetf. Now next is how to use the manipulators to make the formatted console input output operation, that is how to use the manipulators, right? So in the next class I will be carrying your next topic, that is the manipulators, that is managing the output with the manipulators, right? So that's all for today's session. If there is any doubt you can ask from me. So that, thanks a lot everyone. Bye bye.